So in this presentation, we have to talk about the Dirac'S equation. Before enter into the Dirac'S equation, we have to concentrate more on the problems associated with our Klein-Gordon equation. The Klein-Gordon equation does not say anything about the concept of negative energy, which is the major drawback of our KG equation. To solve this problem, Dirac introduced a Hamiltonian. That Hamiltonian is used to explain the concept of negative energy. For the introduction of Dirac'S Hamiltonian, we have to start our journey from the Klein-Gordon Hamiltonian. Say h square is equal to e square equal to c square p square plus m square c power 4 is our Klein-Gordon Hamiltonian. If you want to take the energy value, say we have to take the square root of the right hand side of equation 1. E equal to plus or minus c square p square plus m square c power 4 is the value of energy. Now the E should be replaced by its operator IH cross dou by dou t. Here the momentum operator P equal to minus IH cross delta. So P square equal to minus H cross square del square. If you substitute the value of momentum operator inside the root, we cannot proceed further because the square root of an operator is not yet known. So we may not proceed further. At this moment, to overcome this difficulty, Dirac introduced the value of c square p square plus m square c power 4 as c into alpha x px plus alpha y py plus alpha z pz plus beta mc entirely squared. In this way, he presented the value of c square p square plus m square c power 4. In this above equation, just to take the value of c square outside, then the rest of the terms with the square are separated into two terms, alpha x px plus alpha y py plus alpha z pz plus beta mc into alpha x px plus alpha y py plus alpha z pz plus beta mc. Now we should make the multiplication process. Alpha x square px square, then alpha y square, py square, alpha z square, pz square, then this beta square, mc into mc, m square c square. Next, to take this alpha x px and is allowed to operate with the alpha y py, just multiplication. So alpha x alpha y px py, then alpha x alpha z px pz, then alpha x beta px mc. In this way, do the entire multiplication, we can get the equation of form 4. See, in the left hand side, take the c square outside. So the remaining terms are p square plus m square c square, which are presented inside the square bracket. Now cancel this c square and this one. We can get left hand side as p square plus m square c square, whereas we have to do some modification in the right hand side of equation 4. See here, alpha x square px square alpha y square py square plus alpha z square pz square plus beta m square c square is present as such, no change at all. Here alpha x alpha y px py term is present, then alpha y alpha x py px term is also present. Combine these two terms by this way, alpha x alpha y plus alpha y alpha x entire is multiplied by px py, because px py equal to py px. Px and py are subject for commutation, which means that px py equal to py px. So that I have combined these two terms, alpha x alpha y px py and alpha y alpha x py px are combined as alpha x alpha y plus alpha y alpha x entire is multiplied by px py. In this way, we have to combine the rest of the terms, just 1 and 1, 2 and 2, these two terms, and combine these two terms, 3. Then combine these two terms, 4. Then combine these two terms, beta alpha y beta, 5. Then combine these two terms, alpha x beta, alpha z beta and beta alpha z. The entire is multiplied by PZMC. In this way, all the terms are aligned. Now we can get the equation of form 5. See, the value of P equal to I into Px plus J into Py plus K into Pz. P dot P equal to P square, which means I into Px plus J into Py plus K into Pz dot, once again I into Px plus J into Py plus K into Pz. I dot I 1, so Px into Px square, plus J dot J 1, so Py square, plus K dot K 1, so Pz square. So in this way, P square is equal to Px square plus Py square plus Pz square. In the left hand side of equation 5, P square term is present, whereas in the right hand side, alpha x square Px square plus alpha y square Py square plus alpha z square Pz square terms are present. So the values of alpha x square equal to alpha y square equal to alpha z square is equal to 1, because P square equal to Px square plus Py square plus Pz square. Then in the left hand side, m square c square term is present. In the right hand side, beta square m square c square term is present. So automatically the value of beta square is equal to 1. All other terms are equal to 0 because no alphas and betas are available on the left hand side. But we cannot say Px Py equal to 0. Px Pz not equal to 0. Py Pz not equal to 0. Px MC not equal to 0, Py MC not equal to 0, Pz MC not equal to 0. Therefore, the terms available inside the bracket are 0, which means that alpha x alpha y plus alpha y alpha x equal to 0, alpha x alpha z plus alpha z alpha x equal to 0, alpha y alpha z plus alpha z alpha y equal to 0, alpha x beta plus beta alpha x equal to 0, alpha y beta plus beta alpha y equal to 0, alpha z beta plus beta alpha z equal to 0. From these equations, we can say that, take this equation, alpha x alpha y plus alpha y alpha x equal to 0. Automatically, we can write alpha x alpha y equal to minus alpha y alpha x. Here, alpha x beta equal to minus beta alpha x. Alpha x and alpha y are subjected for anti-commuting property. Anti-commuting means alpha x alpha y equal to minus alpha y alpha x. So, we may say that alpha x, alpha y, alpha z and beta are not numbers but are matrices, because the anti-commuting property is possible only for matrices. Now we can introduce the Hamiltonian H equal to E equal to plus or minus C into alpha x Px plus alpha y Py plus alpha z Pz plus beta MC. This is the assumption we have made at the initial stage. See here, this is the Hamiltonian. H square equal to c square p square plus m square c power 4 equal to this into square. So H equal to c into alpha x Px plus alpha y Py plus alpha z Pz plus beta MC. See, this is the Hamiltonian. Plus or minus c into alpha x Px plus alpha y Py plus alpha z Pz plus beta MC. Here we have to concentrate the positive sign. No need for you to take the negative sign account, because the positive or negative sign can be taken since replacement of alpha by minus alpha and beta by minus beta does not change the relationship between alpha and beta. So we can take the positive sign alone. Hence the Hamiltonian of a free particle can be written as E equal to H equal to C, this value alpha x Px plus alpha y Py plus alpha z Pz is alpha dot P, C into alpha dot P plus beta, see here, C into MC, that is MC square. So E equal to H equal to C alpha dot P plus beta MC square is a Dirac'S Hamiltonian of a free particle. Suppose no force or constant force is acting on a particle, such a particle is called as free particle. In that particle, the value of potential energy is almost 0. On replacing P by minus IH cross delta, that is operator of momentum, and E by IH cross dou by dou t, this is our energy operator. The equation 6 can be modified as IH cross dou by dou t equal to minus IH cross C alpha dot del plus beta MC square. Now allow the entire equation to operate on the wave function psi of r comma t. We can get IH cross dou psi by dou t equal to minus IH cross C alpha dot del psi plus beta MC square into psi. Here alpha equal to I alpha x plus j alpha y plus k alpha z. Then the operator delta equal to I into dou by dou x, gradient operator, plus j into dou by dou y plus k into dou by dou z. So alpha dot delta equal to alpha x dou by dou x plus alpha y dou by dou y plus alpha z dou by dou z. So equation 7 becomes IH cross dou psi by dou t equal to minus IH cross c into, instead of alpha dot psi, we have to alpha dot del, we have to provide the value alpha x dou by dou x plus alpha y dou by dou y plus alpha z dou by dou z. Entire is multiplied by psi plus beta mc square into psi. This is called Dirac'S equation for a free particle. In this Dirac equation, both the space and time coordinates are expressed in first order. That's all about Dirac'S equation.